Hello, my name is Andre Pötsch. I am an application engineer and technical salesman at Botec. If chips remain in the tool flue, we speak of a chip congestion or a chip jam. In this video, I will show you how to identify and prevent such blockage. If the chips are removed too slow through the flue, chips get stuck and cannot be flushed out of the bore, which increases the torque and ultimately leads to a tool breakage. How do I recognize a chip congestion? This can be observed very well with a single flute gun drill. The tool has one flute only, which means all chips must be flushed out by the coolant through the single flute. If the coolant escapes weakly or pulsates, it can be assumed that the chip removal is unfavorable. If no coolant escapes at all, there is most likely a chip buildup that can lead to a tool breakage. With a twin-fluted tool, chip jams are more difficult to detect as the coolant can continue to escape via the second flute. The following approaches help to avoid a chip congestion. The single flute gun drill requires sufficient coolant pressure and a high enough flow rate to safely discharge the chips. Depending on the diameter and the tool type, in conjunction with the drilling depth, it is important to provide sufficient quantity of the coolant so that the chips are flushed out safely, even at the deepest point of the bore. For example, the pressure for a solid carbide single flute tool with a drilling depth of 10 times the diameter, that means 60 millimeters, is 50 bar. The same tool requires a pressure of approximately 80 bars for a drilling depth of 40 times the diameter, that means 240 millimeters. The drilling diameter and the drilling depth must also always be considered at the following points. Due to the machine, the set coolant pressure often does not reach the actual tool spindle. Reason for this could be built-in valves that reduces the pressure, length of piping up to the spindle, changes in cross-section. With the Botec coolant pressure gauging kit, you can precisely measure whether the set pressure of the coolant is actually reaching the tip of the tool. On deep hole drilling machines and some machining centers, oil is used as a coolant lubricant. The viscosity of the oil must be amended to ensure the sufficient flow rate through the internal coolant channel of the tool. In this context, it is essential to observe the filter fineness of the coolant, so that even the finest chip particles do not block the coolant channel. The aim of the actual chip formation during the machining process is to shape the chip in such a way that they provide good contact surface for the coolant lubricant, fit well through the flue, and therefore can be flashed out easily. Adjusting the feed rate and the speed can influence the chip formation to a limited extent. If the processed material nevertheless generates an unfavorable chip, the nose grind has to be adapted. Our experienced applications engineer will be gladly supporting you in the design and optimization of the cutting-edge geometry, which can then be applied by you or the Botec regrinding service team. If you have a current application or need general support, our applications engineers will be happy to assist you from planning to successful implementation.